Yeah, welcome to the new session of the probability and statistics. So, in this, we will see the part of your the introduction to the probability. Introduction to probability. Yeah, as I already informed you that probability means it is one of the case which is called as uncertainty, or also we'll take that probability as percentages also. Percentages. So why I'm taking that as a percentage is, if I take a probability as a sum, example, if I take a probability P is equal to some 0.5, in the part of your percentages, I used to take it as what? The 50% chances are there. Like that, I will discuss it as. So let me take an example. A newly born child is there. That is, a newly born child, or simply we call it as the child born. So let me take the probability of a girl. I'm just taking it as the probability of girl. I'm just taking it as some 60%. That means that what? The probability is nothing but what? Probability of the girl is what? 0.6. Then no need to calculate the what? What is the probability of a boy? So you know that the total probability. You know that the total probability is what? 1. So probability will lies in between. Always the total probability. Always the total probability is equal to 1. Am I right or not? So that is a probability will be lies in between 0 is less than or equal to P is less than or equal to 1. So hence, suppose if I want to calculate the probability of a boy. So what is that? Can you tell me what is the probability of a boy? So you know 100% will be there. Remaining is nothing but what? The 40%. So which is what? 0.4. So that is the reason why that the total probability is what? 1, and which is nothing but what? Sum of all the probabilities. And one more thing, sum of all probabilities, sum of all the probabilities, which is equivalent to 1. That is summation P is equivalent to 1. I can take it as. So these are the initial points. You have to take it as. Yeah. So that you have to consider it as. So while solving a problem on the probability concept, first you have to check it out whether the given probability is 1 or not. So then only you have to apply the problems based upon that one. So in order to understand the concept of your probability, so let me take a few terminologies, so that will help you a lot for understanding the concept. A few terminologies. Yeah, first one will take it as the experiment. First one we will consider it as an experiment. So experiment means nothing but what? You can take any activity with an observable result. Suppose if I am taking an example of the tossing a coin. So if I toss a coin, I need to see the results. So I cannot able to live while toss the coin. Am I right or not? So that is an example. So simply I can take it as any activity with an observable result. With an observable result, I can call it as what? The experiment, simply. So examples, tossing a coin, throwing a what? Dice. Am I right or not? So you know that, so the most peculiar examples in the concept of your probability, what? Rolling a die, right? Tossing a coin, which is called as the unbiased coin. Am I right or not? So there is a difference between biased and unbiased, that I will explain you later. You don't get bothered, right? So these are the things which happens with respect to that criteria. Am I right or not? Yeah. Next one, trials. Next one will be the trials. Yeah, trials. So trials means what? Repetition of an experiment. That's all. Simply it is nothing but what? A repetition of experiment. I used to call it as repetition of experiment is called as the trials. Right. Next one, the outcomes. So what do you mean by that outcomes? What? The results of each trial. Results of each trial, we will call it as what? The outcomes. Okay, so likewise a few terminologies are there. Then again, sample space. This you know that sample space is nothing but what? A collection of all possible outcomes, or simply we call it as what? A set of all possible outcomes. A set of all possible outcomes is called as the sample space. Then one more, sample points. Sample points. So elements in the sample space is called as elements in the sample space. Elements in the sample space is called as what? Elements in the sample space, I used to call it as the sample points. Then event means it is a subset of the sample space. Event is a subset of the sample space. Suppose if I take an example, throwing or tossing a coin. What is our sample space actually? Getting head and tail. Am I right or not? So that getting head and tail, both the cases we used to call it as the sample space. Excuse me. The sample space. So in that, if I calculate the probability of getting head only, that is maybe you will get it as 1/2. Right, similarly probability of getting tail is also 1/2. Am I right or not? So that is also called as what? So it is individual events. See, if I take that probability of getting head is 1/2 and probability of getting tail is 1/2, because the total probability is what? 1. So individual probabilities is nothing but what? An event. So overall head and tail both it is we are considering, means that is nothing but what? That is nothing but what? The sample space. So that is the reason why event is a subset of the sample space. Mathematically this event you can represent it as mathematically this event E is a subset of S. I can represent it as this is we can able to represent this one. Clear with my point? So in such a way that you people have to do the analysis of these criteria. Getting what I'm saying here? Yeah. So before going to that, let me take the definition of your probability. So what is the definition of probability? What is the definition of probability? You will have different types of definitions, but in our engineering point of view, we'll just go through the small definition. So what is that? Probability means what? Yes. So let me take down this. The probability of an event. The probability of an event is defined as the ratio between the favorable cases, the favorable number of cases to the event and the number of outcomes of an experiment. Right. So is called as what? The probability. Nothing is there. So it is the ratio of the number of favorable cases to the number of total number of outcomes. Total number of outcomes means the sample space. So that you can represent it as probability of an event, which is equivalent to what? M divided by N, where M is what? The number of favorable cases, and N is nothing but what? Total number of events. So where m is less than or equal to n, you have to do it as. So this is the definition of your probability. Am I right or not? This is the definition of your probability. So let me take an example. Let me take an example probability that. So tossing a coin, tossing a coin. Yeah. If I toss a coin, what is the sample space method? You know that sample space is what? If I toss a coin, I'll have it as what? Getting head and tail. So this head and tail I used to call it as sample points also. So what is the probability of getting head? Can you tell me what is the probability of getting a probability of getting a tail? Right? Yeah, probability of getting head is what, ma? I have only one option. So that is only one tail will be there, and overall is what? That is one favorable case, and the sample space is what? 2. So hence I can take it as what, ma? 1 by 2. Similarly here also we'll have it as what? 1 by 2. So the total probability is what, ma? If you add these things, which will be 1. So this is called as the probability. This is also called as the probability of a particular event. So likewise you can take many more number of examples. If you roll a die, so rolling a die means what, ma? If I take another example, rolling a die is an example. Yeah, rolling a die is an example. What is the sample space? If I roll a die, what is the sample space? You will have it as a 1, 2, 3, 4, 5, 6. These are the things. So out of which, what is the probability of getting 1, and what is the probability of getting 3? These are all the simple events. What is the probability of getting 5, and what is the probability of getting 6? So check it out. So out of which, a probability of getting 1 ma, so only 1 will be there out of 6 things. So which is 1 by 6. 3 also 1 by 6. 5 also 1 by 6. 6 also 1 by 6. So likewise you people have to see the different types of the analysis of your what more, the probability concept. Am I right or not? Right. So before going to that, I'll list out the things, that is different types of your events more. So first let me give you the clarity of the events actually. So let me take an examples of the events. Different types of events, out of which first I have to consider it as dependent event. What do you mean by the dependent event? Dependent events. So you know that occurrence of one event depends upon the occurrence of the other event is called as what, ma? Dependent events. So note down, occurrence of one event depends upon the occurrence of the other event is called as dependent event. Is called as dependent event. So let me show with respect to a Venn diagram. Let me show this with respect to a Venn diagram. So let me take down. Yeah, if I take this is a sample space. If I take this as a sample space, in which I will take it as the events, like this is an event, and one more. Yeah. So these are the two different types of events, ma. So let me take this is event A, and this is what event B. So if you observe here, the occurrence of A depends upon the occurrence of B. Hence I can call this as what, ma? This A and B are what? Here. A and B are what? Here. Dependent events. Dependent events. Occurrence of A depends upon the occurrence of B. So hence I used to call that as what? Dependent events. Then similarly, independent events. Independent events. Yeah, earlier dependence events, occurrence of one event depends upon the occurrence of the other event in the same sample space. So now here I'm taking it as the independent events. So independent event means what? Occurrence of one event does not depend upon the occurrence of the other event in the different sample space. So that I used to take it as, write down, occurrence of one event does not depends upon the occurrence of other event. Occurrence of one event does not depends upon the occurrence of the other event in the different sample space. In the different sample space is called as the independent events. Is called as the independent events. Yeah, similar to your earlier case. If I show that with respect to your, if I show you with respect to that an event diagram. So here I have to consider it as two different sample space. Two different sample space I need to consider it as. Yeah, out of which, so this you should take it as a sample space. This also you take it as a sample space. Yeah, in that particularly I have to consider it as what? An event. So this is an event. Similarly here also this is an event. Yeah, both are same only this is event A and this is event B. So see here, occurrence of A does not depend upon the occurrence of B, hence I can call this as what? Hence I can call it as what? Independent events. Am I right? So likewise you have to define this one. Then based upon that, one more thing will be there, which is mutually exclusive events. Mutually, another one, mutually exclusive events. Mutually exclusive events. Yeah, here this is also the thing. Mutual exclusive events is nothing but what? Occurrence of one event does not depend upon the occurrence of the other event only, but it is in the same sample space. Which is similar to your independent events only. What is the independent event? Occurrence of one event does not depend upon the occurrence of the other event in the different sample space. But mutual exclusive events is what? It does not depend upon the same sample space. So let me give you the clarity regarding this mutually exclusive events. So let me take that. So if the occurrence of one event does not depends upon the other event in the same sample space, is called mutually exclusive events. So let me give you the clarity regarding this. Take a Venn diagram. So I have a sample space here. Here let me take, this is my sample space, which is yes, yeah, in which the event A I am taking here. Yeah, one more event. This is another event. So this is event A and this is event B. So if you observe here, occurrence of A does not depend upon the occurrence of B, but it is in the what? Same sample space. It is in the same sample space, which is called as what? Which I used to call it as what? Mutually exclusive events. If you are observing here, what is the A intersection B here? Can you tell me what is your A intersection B? Is there any common part that is existing here? A intersection B, like suppose if I take this is A and this is B, A intersection B is nothing but what? there is nothing is there, so which is a null set. So accordingly, what is the probability of your A intersection B, which is a null set? So probability of A intersection B will be what, ma? 0. So for mutually exclusive events, this I used to take it as mutually exclusive means ME. For mutually exclusive events, directly you can represent as what, ma? Probability of A intersection B is equal to 0, and that is A intersection B is what? It is a null set. A intersection B is nothing but what, ma? Which is a null set. Clear with my point? In such a way that you people have to do it as the things with respect to your mutually exclusive events. Again, if you are having a doubt that, so let me take an example, ma, for understanding this mutually exclusive events particularly. So take one more example. So here I'm just taking a thing, 2 dice are rolled. Suppose if I take it as 2 dice are rolled. I'm just taking an example. 2 dice, if it is rolled, means if 2 dice are rolled, what is the sample space? What is the sample space, ma? You will have it as what? 2 dice means 6 square, which is nothing but what? 36 sample space will be there. What are those? 1 comma 1, 1 comma 2, 1 comma 3, and so on, 1 comma 6. Likewise, 2 comma 1, 2 comma 2, and so on, 2 comma 6. So likewise, you people have what? Different strategies. So and so on, like that, 3 comma 1, that. So you'll have it as what? 6 comma 1, 6 comma 2, and so on, 6 comma 6. So this is the sample space. If I rolled 2 dice, am I right or not? So here, this is what the criteria. Let me take the probability of sum 7. If I take it as, what is the probability of sum 7, and what is the probability of sum 11 if I take it as? Yeah, what are the probability of getting sum 7 properties? Sum 7 means what? What is the possible cases you are having here? The probability of getting sum 7 is like 1 comma 6, then 2 comma 5, then 3 comma 4, then 4 comma 3, then 5 comma 2, and last one will be the 6 comma 1. Am I correct or not? So total we are having here what, 1, 2, 3, 4, 5, 6 will be there. So hence out of which is nothing but what, 36 will be your sample space. So which is nothing but what, 6 divided by 36. Similarly, probability of sum 11. Sum 11 means what? You will have it as what? One is 5 comma 6 and the other one is what, 6 comma 5. Am I correct or not? Yes or no? So what is this? What is this, ma? 2 by 36. So here, take this probability of getting sum 7 is event A if you take it as, which is an event A. And this is what, ma? This you should take it as what? Event B you take it as. So check it out, which is for both the events, the same sample space I'm using here. Is there any A intersection B? See, check it out. If I take it, this is A, this is B. Is there any intersection point will be there? Is there any intersection point, ma? No. So hence these two events are what? Mutually exclusive events. So why I am calling this as a mutually exclusive events? Occurrence of A and occurrence of B does not depends. Occurrence of A does not depends upon occurrence of B in the same sample space. So hence I can call that as what? Mutually exclusions. For such type of mutually exclusive events, the probability of A intersection B is what? 0. I can tell it as directly. Am I right or not? So this is the part of your mutually exclusive events. So this I can conclude that this is nothing but what, your mutually exclusive events, I can call it as. Clear with my point? So that is the meaning of your mutually exclusive events. Got my point? I hope you understood this one. Am I right or not? Yes or no? Yeah. Next one, exhaustive events. Next one will be the exhaustive events. Next one will be the exhaustive event. So a set of events is said to be exhaustive if it includes all the possible events, right, together, means it includes all the possible events. It includes all the possible events. Means exhaustive means what, ma? You could take you can take an example. My limit of see, in the morning my limit of tiffin, which is, if I take it as a idli, ma, only 5 idlis is my limit. So if more than 5 idlis if I'm taking, you are taking, means what? It is an exhaustive things. So like that, it includes all the possible outcomes, it includes all the possible events, which is nothing but what? Exhaustive events. Let me take an example, tossing a coin, ma. If I toss a coin, there are two outcomes. One is getting head and getting tail. Is there any other part? And there is no third possibility. Am I right or not? So take down that example. So if I take an example, if I toss a coin, right? So this is the thing. Tossing a coin. What? There are what, ma? Two exhaustive events. If I toss a coin, there are two exhaustive cases or events. Two exhaustive cases or events. That is either what? Either head or tail. And there is no third possibility. Am I right or not? And there is no third possibility. Is there any third possibility? No. So such type of things I can call it as what? This I can call it as what, ma? The exhaustive events. Clear with my point? Getting what I'm saying? And the final one, on one more thing, equally likely events. Equally likely events. Yeah. Equally likely events means what, ma? If one of the events can't be expected to happen in preference to the another, then such type of events are called as what? Equally likely events. Am I right or not? So let me take an example. I mean, write down that definition. If one of the events can't be expected to happen in preference to another, then such type of or such events are called as what? Are called as equally likely events. Take an example. If I take or tossing a coin only, I told you just what is the sample space? Getting head and tail. Can you tell me what is the probability of getting head, ma? You already know that probability of getting head is half, and probability of getting tail is also what? Half. Both are case what, ma? What? Both the cases are what? Half only or not? Equally likely. And one more thing, if I take it as a rolling a die, if I take it as what is the sample space here? I'll have here what? 1, 2, 3, 4, 5, 6. These are the sample space. Here what I used to take it is probability of getting even number. What's the probability of getting odd number? Can you tell me? Even odd number means 1, 3, 5, which is 3 by 6. And probability of even number, even number is also 2, 4, 6. Odd number is 1, 3, 5, which is 3 by 6. So the values for this is 1 by 2 and 1 by 2. This is also what, ma? Equally likely events. Am I right or not? So likewise, you people have a different analysis. Clear with my point? Understood what I'm saying here? All. So these are the some of the things which you have to keep in your mind, right? So these are the different types of your events. Okay, getting what I'm saying? Yeah. Now let me start with the concepts of your what some of the results of your probability, right? So if you are understanding all these concepts, that helps a lot to solve the problems in your to solve the problems in your probability concepts. So let me take the results of probability. Let me take the results of your probability. Am I right or not? Results of probability. Yeah. So results of probability means what, ma? You know that probability of a sample space, which is nothing but what? One, you know that. Similarly, this is what? Probability of sample space. Probability of sample space is always is equivalent to 1, ma. Yeah, next one. Probability which is lies in between what? Probability of any event which is lies in between what, ma? 0 to 1. So here, if probability is equal to 0, I can call it as what, ma? That is not possible, but anyhow we are writing. So probability of an event is equal to 0. It is not what? It is impossible event. I used to call it as, which I used to call it as what, ma? Impossible event. If probability of an event is 1, I can call this as what? Which is a sure event. Exactly, it will happens like that. We'll discuss it as. Yeah, next one. What is the probability of a complement, ma? What is the probability of a complement here? Yes. How you will define this one, probability of a complement? So let me give you the clarity. If I take the Venn diagram here, let me take one Venn diagram. Yeah, this is a sample space. Yes, in that sample space I'm taking one event here. Yeah, this is an event A. If I take it as, yeah, outside you people are having an event which is nothing but what, ma? A complement. And you know what is that? If I represent this one, ma, if I represent here A union A complement, so which is nothing but what? A sample space, na? Yeah, if I apply the probability here, what I'll have it as probability of A union A complement, which is equivalent to what? The probability of sample space. So what is this? Probability of A union B, if you take it as probability of A plus a probability of A union, A complement, and there is no intersection part. If you want, you can represent it minus a probability of A intersection A complement, which is equivalent to probability of sample space is what, ma? 1, you know that. So this is what? Mutually exclusive ones. This value will be what, ma? 0. So now I'll have it as what? A probability of A plus probability of A complement is equal to 1. Directly I can represent as what? What is this? Probability of A complement is equal to what, ma? 1 minus probability of A, I can able to mention here. So now what is the probability of A complement here? What is the probability of A complement value here? 1 minus probability of A, I can able to mention. This is the part of your what? The results, one of the result. Next, let me take the another result which is called as what, ma? The addition theorem. Suppose if I take it as the addition theorem, which is fourth one, ma? Fourth one, which I used to take it as the addition theorem. I used to call it as that. You know that all of you are very familiar with this. Just now I written the probability of A union B is equal to probability of A plus probability of B and minus probability of A intersection B. So here, if A comma B are two events, if A comma B are the two events, then the addition theorem will be probability of A union B is equivalent to probability of A plus probability of B minus the probability of A intersection B. I can able to write down. So this is the addition theorem. Very useful formula, ma, here. These are all simple strategies, right? If A comma B are the two different events, I can represent this one as that. Suppose if I go with three events, if I go with the three events, if A comma B comma C are three different events or three events, then what is the probability of A union B union C is probability of A plus a probability of B plus a probability of C minus a probability of A intersection B minus a probability of B intersection C minus a probability of C intersection A or A intersection B plus probability of A intersection B intersection C. Recently, one of the previous gate question they asked you directly they given three different types of events. That problem I will solve it as, you don't get bother. So recent one of the previous gate question based upon this three different events properties, probability, they asked directly. So just remember this property, just remember this, you will get it as the criteria. Clear with my point? Yeah, suppose if A and B are, A comma B comma C are the mutually exclusive events. If A and B are the mutually exclusive events, so what you people will have it as here? Yes, if all the three different events, if A comma B comma, note point, if I take it as, if A B C, I just taken it as what, the events. If A comma mutually exclusive events, if A comma B comma C are mutually exclusive events, what will happen? Can you tell me? For a mutually exclusive events, intersection part will become 0. Probability of A intersection B is 0, B intersection C is 0, C intersection A is 0. All the things it will become 0. Am I right or not? In such a case, how I can able to write down? If A comma B comma C are the mutually exclusive events, means probability of A intersection B, probability of actually mutually exclusive events means intersection will become 0. In such a case, how I can able to represent this probability of A union B and probability of A union B union C? How I can able to represent it as? So there is no intersection part. Probability of A plus a probability of B. Then this one I can able to represent as what? Probability of A plus probability of B plus a probability of C I can able to mention it as. So this is the part. So if A and B, A comma B comma C are the mutually exclusive events, there is no what? There is no intersection points here you are having. So in such a way that you people have to do the conditions here. Clear now? So that is the part of your mutually exclusive events. Next one will be what? I think which is number, I think it is number 5. I had to take it as, yeah. Let me take the number 5. Number 5, which is nothing but what? Multiplication theorem. Next one will be the multiplication theorem. So here I have to consider it as two different cases. Multiplication theorem for first one is dependent events. Means what? Occurrence of one event depends upon the occurrence of the other event. Yeah, in that case, first I have to take it as the dependent events. If A and B are the events, then what is the probability of A intersection B? Multiplication theorem means what? Intersection B. So which I can represent as probability of A into probability of what? B given A I can represent as. So here there is a conditional probability. This I used to represent as what? This one. Or one more, this itself I can represent as probability of B into probability of A given B. Probability of A given B. So this is the dependent events multiplication property. Try to understand this one, where this probability of A given B and probability of B given A are the conditional probabilities, we used to call it as, or I will take it as what? Conditional probabilities. Yeah, why it is called as the conditional probabilities? Why you are calling it as the conditional probability? See here, from this I can represent here. See check it out. How I can able to represent this as? From this, can you tell me what is the probability of A given B? Can you tell me what is the probability of A given B here? See, this is the part. Actually, probability of A intersection B is equivalent to probability of B into probability of A given B. From that I am asking you, probability of A given B is equivalent to what? I can represent as what? Probability of A intersection B divided by what? Probability of B I can represent as. Similarly, probability of B given A, how I can able to mention? Probability of B given A, how I can able to mention? Probability of B intersection A and A intersection B, both are the same. So here, probability of A intersection B I have to represent it as, and probability of A I will represent it as. So these two are, I can call it as what? Just now I told you that. So these two things I used to call it as the conditional probabilities. These two I used to call it as the conditional probabilities. So what is the use of these conditional probabilities? Why you want to use it as? See, check it out here. The thing, this conditional probability, why I'm using is here I'm representing the unknown events in terms of the known events. The unknown events in terms of the known event I'm representing here. Clear with my point? So here there will be a thing. The A value is your known event. A value is known and B value is unknown. Right, so that is the reason why unknown event I'm representing in the this is a reverse I written. This is A is unknown event and B is unknown event. B is unknown event. Right, here also B is unknown event and A is unknown event. Okay, so the usage of your conditional probabilities is I'm writing the unknown events in terms of your known events. That is the usage of this one. For understanding this, let me take an example. I will continue that multiplication theorem. You don't get bothered. Let me take an example for understanding the conditional probability. So let me take an example. So for understanding this conditional probability, how I am representing that unknown events in terms of known events. So a die is rolled. A die is rolled if the number is odd. A die is rolled if the number is odd. Then find the probability for prime number. Then find the probability for prime number. This is the question. Yeah, understand this question and give me the solution for that. What they had given is a die is rolled. The number is what? Odd number. Am I right or not? They know they given that one. But they are asking what? They are not asking directly the probability of odd number. They are asking what? They are asking what? Probability for prime number. That means odd number given prime number. That is what the question. See, if a die is rolled, you know that sample space is what? 1, 2, 3, 4, 5 and 6. This is a sample space. Am I correct or not? So if a die is rolled means that is a sample space, out of which you know that 1 is odd number, 3 is odd number and 5 is odd number. These three are the odd numbers. Am I right or not? They given what? These are the things. So what's the probability of getting odd numbers? What's the probability of getting odd numbers? Which is nothing but what? 3 divided by 6. Am I right or not? And they are not asking directly the probability of your odd number. So given odd number, prime number thing they are asking. Am I right or not? You know that what is the prime numbers? 2, 3, 5 is the prime numbers. Am I correct or not? Yeah. So now they asked the probability is probability of what? Probability of what? Yes, prime number. Given that what odd number or not they had given? Yes or no? So here prime number is my unknown event. So let me check it out. Prime number is unknown. Where my prime number is unknown and odd number is what? Odd number is what? My odd number is known event. So now if I represent that probability of prime number intersection odd number divided by, you can take probability of A given B. So probability of A given B is what? Probability of A intersection B by probability of A. So which is this one. So now let me give you the thing. What is yeah, here also this I just calculated. Probability of odd number is what? 3 by 6. Can you tell me what is your probability of a prime number intersection odd number? Prime number intersection odd number. You are having what? Prime number intersection odd number. So this is 3 and this is what? 5 you people are having. So which is nothing but what? 2 divided by 6. So now substitute this prime number intersection odd number, which is 2 by 6 divided by what? Odd number will be what? 3 by 6. So 6 will get cancelled. You will have it as what? 2 by 3. So this is a best example of giving the analogy of what? The analysis of your what? The conditional probability. So here the given what? Given prime number, odd number thing they are asked. The number is what? Odd number. Based upon that they asked you what? The prime number probability. So this is the best example of what? The conditional. It is a best example of your conditional probability. Clear my point? So such a way that so the usage of your conditional probability is nothing but what? Writing unknown events in terms of your known events. So that is the best ideology of your conditional probability. So this conditional probabilities happens with respect to the independent, the multiplication theorem. Clear my point? I hope you understood this one. Right? Yeah, that is the best example I can solve it as. So then this is for one point of view. Next thing is what? if A comma B comma C are three events, if A comma B comma 3 C are the three events, then what is your probability of A intersection B intersection C ma? What is the probability of A intersection B intersection C here? You will have it as what ma? Probability of A into probability of what? B given A into probability of what ma? C given A intersection. So this is the part of that criteria. Clear up my point? So this is for three events. Okay, so likewise you people have to go through with the respect of what ma? The multiplication theorem for, this is the multiplication theorem for what? Dependent events. Then similarly if I go with for independent events. So let me take the second case, which is nothing but what? For second cases, which is independent events. Means what? Earlier is dependent events. Occurrence of A depends upon the occurrence of B. That is the reason why I represented there. So now when it comes to the part of your independent events, occurrence of A does not depend upon the occurrence of B. In such a case, I have to go with respect to what? The different strategies. So can you tell me what is this one? A and B are the independent events. My independent events means what? Occurrence of A does not depend upon the occurrence of B. So what you people have it as? A intersection B I can represent as what ma? Probability of A into probability of B I can represent it. So that means A and B does not depends upon the different does not depends upon the different sample space. Similarly, A intersection B intersection C I can represent as what? A intersection B intersection C I can represent as what ma? Probability of A into probability of B into probability of C I can mention there. Clear na? This is how we have to do it. Getting what I'm saying there? So these are the points which you have to keep in your mind to solve a problem on your what? To solve a problem on your what ma? The probability concept. Understood? Understood or not? Are you getting what I'm saying here? Yeah. Next, let me take one more last note point. Last point. I think which is number 6. I think so. Yeah. If I take the small generalization part of this one, if A and B are the two events, then I want to calculate the probability of A intersection B complement and probability of A complement intersection B I want to calculate. So for understanding this, I'll take the Venn diagram. Let me take the Venn diagram here. For understanding this, I'll just take a Venn diagram. Just a minute. Just a minute, ma. Yeah, I'm just trying my best level because or else will nothing is there, ma. Or else directly I will take the thing with respect to, don't get confused. Yeah, this is event A. Yeah, and one more thing will be, it is an event B, which is a sample space. This is event A and this is event B I'm taking. Yeah, can you tell me what is this portion? This you know that very well, which is nothing but what? A intersection B, that you know that, right? So which is A and this is B. Yeah, suppose if I want to take only A, if I want to take only A, how I will do it as? If I want to take only A, how I will represent as? This portion I am calling it as what? Only A means, which is A minus B. And this portion, shall I write it as what, ma? Only B means what? B minus A can represent as. Am I correct? Yes or no? Yes? Yeah, that is how I have to represent it. What I'm telling is, only A means this itself. This itself I'm representing. Only A means, see, check it out here. This is minus B, ma. This minus B I can represent as what? B complement only, na? This shall I take it as A intersection B complement. Similarly, this shall I take it as what? My B minus A, which is nothing but what? A complement intersection B. Shall I write it as? Yes or no? Am I correct or not? Yeah. A intersection B complement means I'm just taking it as what, ma? From A minus this portion, this A intersection B. So this itself I can represent as what? This I can represent as what, ma? A minus what? A intersection B. Similarly, this also what? This is nothing but what? What I can represent as B minus A intersection B or not? Yes or no? So based upon that, what I used to tell is, if I consider the probability for that, so only A if I go it as, only A if I'm going, I can represent as what? Probability of A intersection B complement I can represent as. So for that, probability of A intersection B complement, what I represented here? Probability of A minus probability of what, ma? A intersection B I can represent as. So this is the part of your what, ma? Only A I can able to mention here. Only A I can represent it here. Similarly, can you go for only B? Can you go for only B, ma? Only B means what? A probability of A complement intersection B I can represent as. Am I correct or not? Yeah. Similarly, how I will represent this one? Probability of B minus probability of what? A intersection B I can represent as. Am I correct? That is what, for knowing for giving the analysis of this, I just taken that Venn diagram. That's all, nothing more than that. Clear with my point? Clear with my point? Yeah. Sometimes they will ask you only once, ma. That is either of this one. That is only once. Sorry, only once. If they ask you, only once means what? Either A or B you can represent as. So that is either A or a B you have to represent as. So that you can have it as what? That I can mention you here is what, ma? Probability of only once means what, ma? Delta I used to represent as A delta. Probability of what? A delta B I can represent as this. The either A or B means what? Both the cases. That is a probability of A intersection B complement plus probability of A complement intersection B I can represent as. So this I used to take it as what, ma? Either, that is what? Either A or B, that is only once I can represent as. Next, one more case. Next, another case, ma. Neither A nor B, or which is also called as none of AB, or which is also called as what, ma? Not in AB also. These all are what one and the same. In such a case, how I will represent as probability of A complement intersection B complement, which also I can represent it as, I can represent as what, my probability of A intersection B whole bar. This I can able to mention you it as 1 minus probability of A union B. I can represent it as 1 minus probability of A union B. I can represent it as. So these are the different types of the things which you have to keep in your mind to solve a problem. Sometimes they will ask you directly, these are the strategies. Clear with my point? These are the strategies. And let me take the note point. Let me take the note point here. Right. So let me take a note point. Yeah. Let me take the example point of this. So you know that the conditional probability. What is the conditional probability, ma? In the earlier thing, conditional probability is what? Conditional probability, that is a probability of A given B, which is equivalent to what? A probability of A intersection B divided by probability of B, that you know that. Am I right or not? So by using this analysis, can you try? By using this analysis, can you try what is a probability of A given A complement given B? What is the probability of A given complement B, ma? A complement, probability of A complement given B. This I can represent as what? Probability of A complement intersection B divided by probability of B I can represent as. So this also, what is your probability of A complement intersection B, which is probability of B minus a probability of A intersection B divided by what, ma? Probability of B. Yeah, this value will be what? 1 minus probability of A intersection B divided by probability of B. I can mention you here. So this is one of the strategies. Sometimes they will ask you that such type of questions. Clear with my point? So in that thing, you are in a position, you have to give me the answer for that. Similarly, can you go for what? A probability of A given B complement. What is the probability of A given B complement? Again, probability of what? A intersection B complement, which is equivalent to what? Probability of A given B complement divided by probability of B complement. Yeah, this how you can able to mention here. Probability of A minus probability of A intersection B divided by 1 minus probability of B I can represent it. Am I right or not? So provided that probability of B is not equivalent to 1. If it is 1, then it will become 0. Am I right or not? Yeah, this is one of the things. Then the last one will be what? Probability of A complement given B complement. Probability of A complement given B complement, which is probability of A complement intersection B complement divided by probability of B complement. This I can represent as what? 1 minus a probability of A union B divided by 1 minus a probability of B. In this case also, probability of B is not equivalent to 1. Am I right or not? So these are the different strategies which you have to keep in your mind to solve a problem on your what? The probability concepts. Okay, so these are the basics required to solve a problem on your what? The thing. And one more note point. See, in the concept of your probability, let me take this one. Usually we will call it as what, ma? At least means what? At least, and other one is at most. Next one will be and the other one is what? R. Yeah, this if I take it as at least means what, ma? At least means what? Minimum to the maximum. So hence I used to take it as what? The maximum value. At most means from maximum to the minimum value. So this is minimum. And means what? You know that, which is a product. And R means what? R means the addition. Yeah, symbolically you will represent as what? What is the symbols for this? What is the symbols for this? Usually we will take it as maximum means what, ma? Greater than or equal to. Minimum means less than or equal to. Product means intersection. Addition means union. So this is also very important to solve the problem on your what? The concept of your probability. Getting what I'm saying here? So this also will be useful for this case, right? So this is also very important. Okay, yeah, fine. So this is about the thing. Clear with my point? Understanding what I'm saying here? Yes or no? Understanding what I'm saying here? Yeah. Yeah, likewise, you people have to keep in your mind the part of your the probability and statistics part. So for understanding, yeah, let me take some more examples based upon that. So if I take the things, different types of examples they will ask you in the GATE exam point of view. One is, I told you already, tossing an unbiased coin. Tossing an unbiased coin they will ask you. So what is the difference between the biased and unbiased coin here? What's the difference between biased and unbiased? Unbiased which is also called as a fair coin, and biased, which is called as unfair. Yes. Can you tell me what is the difference between these two things? Unbiased means nothing is there, ma. See, if you take your coin, so one side head and one side will be the tail, ma. So that is, both the faces are different. Both the faces are different. Both the faces are different. We used to call it as what? The unbiased. Suppose if I take the biased or unfair, both the faces are same. Both the faces are same. Means either head, two sides, either head or two sides, either tail. It depends upon the situation. They will design that criteria. Getting what I'm saying here? Understood. So that is the meaning of the unbiased coin, biased and unbiased. So unbiased means both the faces are different, one side head and one side tail. Biased means what, ma? Both faces are same. Okay, so this is the difference. See here, if I take the tossing a coin as an example, ma. So let me take the clarity. If I toss one coin, what is the sample space here? Which is 2 to the power of 1, that is a 2. Sample space S is nothing but what, ma? Head and tail you will have it as. Similarly, 2 coins if I tossed. 2 coins if I am tossing, sample space is a 2 square, which is a 4. Then you will have it as what? Sample space is what, ma? Head head, head tail, tail head and tail tail. Am I right or not? So here they will ask you this. If a coin is tossed twice or 2 coins are tossed, what is the probability of getting same phases? What is the probability of getting same phases, they will ask you. So can you tell me what is this? Same phases means what, ma? You will have a head head, tail tail. Only 2 cases will be there. So my possible cases is what? 2. And total number of cases is what, ma? 4. Am I right or not? So which is this one. Similarly, can you extend this for your 3 coins? 3 coins if I tossed. What's the sample space? Which is 2 power 3, that is 8. Yeah, sample space is nothing but what, ma? Head head head, head head tail, head tail head. Am I right or not? Yeah. Next one, tail head head, tail head tail, tail tail head. How many are there? 1, 2, 3, 4, 5, 6. One more is what, ma? Yeah, head head head, head tail head, head tail tail. Yeah, head head tail. You will have it as what? Sorry, yeah, it is there. One more will be what? Tail tail tail. One more case is what, ma? Yes. You will have it as what? Head head tail. Sorry, check it out here properly. Head head head, head tail, head tail head, tail head head, tail head tail, tail tail head. What is another case? What you will have it as? Yes. Yes. One more thing you will have it as what, ma? Head head head, head head tail, head tail head, tail head head, tail head tail, tail tail head, and one more will be what, ma? Head head what? Tail. Am I correct or not? Check it properly here, whether you are getting the same thing or. Yeah, so there are 8 possible cases. Tossing a coin 3 times. So you will have these are the possible cases. Yeah, in these also, can you tell me what is the probability of getting same phases, ma? What is the probability of getting same phases? Again I'll have it as what? Which is head head head, tail tail tail. So which is possible cases is what? 2, but it is nothing but what, ma? 8. Am I correct or not? Yeah. If you check it, suppose if I asked you n coins. Suppose if I asked you n coins, I have here what, ma? Sample space is nothing but what? 2 power n is the sample space. So in that case also I want to calculate what? The what the probability of getting same phases. So I want to generalize this one. So if you observe here, this I can represent as what, 2 by 2 square, because 2 times I tossed. Similarly for 3 coins I can represent as what, 2 by 2 power 3. So that value you can do it as. Similarly here also the generalization, probability of getting same phases. The probability of getting same phases is nothing but what, 2 divided by 2 to the power of n, where n is nothing but what, the number of times the coin is tossed. Clear with my point? So this is the part which you have to keep in your mind to solve your problem. To solve your problem on what, the concept of your the probability. Similarly, can you try this for your what, the die? Similarly, can you try this for your die? Is it possible? Yeah. Take an example that. So take that example also. Right. So that is rolling a die. Rolling an unbiased die. Rolling an unbiased die. Okay. Yeah. So rolling an unbiased die. What is the sample space here? You know that what, let me take the thing with respect to what rolling an unbiased die means. First one die if I rolled. What is the sample space? 6 power 1, which is a 6. That is, the sample space is 1, 2, 3, 4, 5, 6. This is a sample space. And 2 dice are rolled. Yeah, 2 dice if I rolled, my sample space is 6 square, which is 36. That you know that. So sample space, if I write it as, I'll have it as what, 1 comma 1, like 1 comma 6, and so on. You will have it as what, you know that 6 comma 6 will be there. Right. Then can you tell me what is the probability of getting same sample space? What is the probability of getting same phases? What are those, ma? You will have it as what, the same phases means what, like 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. So these are the things. So what is the answer for this? Total 6 will be there. 6 divided by sample space is 36. Similarly, can I try for if I roll 3 dice? So if I roll the 3 dice, my sample space is what? 6 cube. Am I right or not? So again I'll have here what? The sample space is nothing but what, 1 comma 1 comma 1, and so on. I'll have here again 6 comma 6 comma 6. In which case, this case also, the same phases will be what? What's the probability of getting same phases here? What's the probability of getting same phases, ma? Right? Same phases means what? Same 1 comma 1 comma 1. One more it will be added. So that is what? 6 divided by, you will have it as what, ma? 6 cube. So similarly your dice, similarly your coin, I want to generalize this one. So if I roll n dice, I'll have the sample space is what, ma? 6 to the power of n. If I want to generalize this, you'll have it as what? This second represent as what, ma? 6 divided by 6 square. This is nothing but what again? That I already represented, which is what, ma? 6 divided by 6 cube. Similarly for this, what is the probability of getting same phases? What is the probability of getting same phases, ma? So for what I can say that for n dice, if I rolled, what is the probability of getting same phases? I can represent as what? 6 divided by 6 to the power of n. This is the generalization part. This is the way of solving a problem. I mean, the things which you have to keep in your mind to solve a problem on your what, ma? The probability concept. So generalize these things. Yeah, and one more thing you can represent here. One more thing you can represent it here. Yeah, likewise things you have to keep in your mind to solve the problems on the concept of your probability. Okay, so let me start with the problems so that you will have an idea how you people have to solve the problems. Yeah, so before solving that, one more thing, I just discussed only rolling a die as well as the tossing a coin, and third example also they will ask you. Yeah, let me finish that, then we will start the problems. The third one will be what? what? A drawing a card from a pack of 52. So drawing a card from a pack of 52. You know that it's a deck which is having a 52 cards, right? So out of which 52 cards, you will have a what? 26 cards. 26 cards red and 26 cards what ma? Black. Am I right or not? 26 cards reds and 26 card black. So again these 26 will be divided into 13 cards. 13 cards. Am I correct or not? So again this will be classified into 13 and 13. Yeah, 13 means what ma? From where it will starts? A means 1, 2, 3 and so on. 10 will be there. Then you will have it as what? The other thing, J, K, Q. Am I right or not? So Jack, Queen, King. Right. J, Q, K. Right. So this is how for all these things, you people will have that criteria. Yeah, so there are 13 cards like this. So usually these 3 cards we used to call it as fees cards. These 3 cards we used to call it as fees cards, that you know that. Okay, so and that to this 13 will be what ma? You know that hearts. Sorry, here I did not mention the things. So which is red cards, and this is what ma? Black cards. So which is red. You will have it as a hearts, which is diamonds, and clubs or spades used to call it as. Right. So these are the different strategies you will have test. So out of which if I pick one card, then what is the probability of that? So they will ask you that things. Clear with my point? So likewise the problems they will ask you. Then recently they included one more thing also, ma. They will have a earn or a thing. So picking a ball from tub or earn, they will ask. Earn. You used to call it as the earn. Ma. See, sometimes they will ask you the questions like simple strategies only. Yeah, an earn contains. Let me take an earn contains. You will have it as what ma? Suppose if I take this as an earn, this earn contains 4 black balls, 4 green balls and 4 red balls. So randomly one ball is picked. Then what is the probability of getting that ball is 3 balls are picked up. 3 balls are picked up. All the 3 balls are red. What is the probability of getting that all the 3 balls are red? They will ask you. So such type of questions they will ask you. See, here total 12 balls are there, out of which they taken it as what ma? 3 balls. So those 3 balls must be what? The red balls. So like that, see, here you have to select it as what ma? The combinations. So required probability is nothing but what? Out of 4 red balls you are having here. So 4C3 divided by what ma? 12C3. So whatever the value you are getting, that you have to do it as. Or otherwise, one more thing also you can do it as. See, 3 balls they had taken randomly, 3 balls. So first ball will be what ma? First ball will be what? The red ball. So that means that 4 divided by total will be what? 12. So one ball picked up. So hence again you will have it as what? 3 ball divided by 11. Then similarly it is nothing but what ma? 2 divided by 10. Whatever the value you are getting, that you have to get the answer. So likewise, see, don't expect all this. Sometimes they will ask you such type of questions directly, and sometimes they will ask you with repetition, without repetition, simultaneously they picked the ball and they discarded. So likewise, different strategies of the problems they will ask you in these criteria. So these are the peculiar examples. They will concentrate on this concept of your probability. Getting what I'm saying here? Yeah. So let me start with the problems so that you will have an idea. So let me take these things, problems. Let me take the problems. Yeah. If a coin, or if 3 coins are tossed at a time, if 3 coins are tossed at a time, if 3 coins are tossed at a time, find the probability that if 3 coins are tossed at a time, find the probability of getting find the probability of getting at most one head. Find the probability of getting at most one head. Find the probability of getting at most one head. So this is the probability you people have to do it as. So tell me that how you will do it as. This I already told you that 3 coins are tossed. So 3 coins are tossed means the sample space is what ma? 2 power 3, which is 8. So what are that sample space? Sample space is what? Head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Am I right or not? So total 1, 2, 3, 4, 5, 6, 7, 8. So total 8 sample spaces are there. So they are taking it as what ma? At most. They told you that what? At most. At most means what? Your earlier case, at most means less than or equal to. So that is, if I take it as at most, probability of getting at most x is less than or equal to 1 here. Am I right or not? So x is nothing but what here? I'm just taking that x is what? Number of heads I'm taking here. At most probability of getting what? The utmost thing. So x is less than or equal to 1 means, so this you can represent as what? Probability of x is less than 1 plus probability of x is equivalent to 1 also. So both the cases, less than as well as your 1. Yeah, then what is the probability of getting x is less than 1 means what? X is equivalent to 0, then which is same as is of what? Probability of x is equivalent to 1. I have to do it as. So x is equal to 0. What is the meaning of that one? Number of heads is 0. So what are this number of heads? Which case it is having? In which case you are having number of heads is 0? This is this one. So that is 1 divided by what ma? 8. Then next exactly 1 head. Here exactly 0 heads. Am I right or not? So exactly 1 head means what? What are the cases here? 1, 2. Sorry, this is not exactly 1 head nama. Yeah, sorry. Exactly 1 head means this is 1, 2 and 3. So total 3 will be there. So 3 divided by 8, which gives you what? Which gives you what here? So which is nothing but what ma? 4 by 8. The answer for this is what? 1 divided by 2. So this is the answer. So or else directly you can go it as ma. At most means what? Directly you can tell it as 0 and 1. At most means either 0 or 1. So directly you can do it as. So that is how you people have to solve the problem based upon that. So can you go for in the above problem, repeat the above problem, or in the above problem find the probability that at least one tail. Find the probability that at least one tail. Can you give me that at least one tail? So now I asked you people that is what? At least one tail. Yeah, just now you calculated what ma? That. Yeah, so you can go with respect to what? At least one tail means probability of at least means greater than or equal to 1. So where x is nothing but what? Number of tails. Yeah, so which is equivalent to what? This greater than or equal to 1 I can represent as what ma? 1 minus probability of x is less than 1. 1 minus probability of x is less than 1. So again less than 1 means what? This is 1 minus the probability of x is equivalent to 0. You can tell it as. So x is equal to 0 means what? Number of tails is 0. Only one head. So that is the possible case. 1 minus 1 by 8, which is nothing but what ma? 7 by 8. So this is the answer for that. Clear with my point? Yeah. So that is how you people have to go through it as. Getting what I'm saying there? Yes ma. Yeah. So likewise, next one more thing. Next problem. Let me take that. Next problem. 2 dice are rolled. 2 dice are rolled. Find the probability that 2 dice are rolled. Find the probability that the first die should contain find the probability that the first die should contain a prime number. The first die should contain a prime number or a total of 8 or a total of 8. This is the question. 2 dice are rolled. Find the probability that the first die should contain a prime number or a total of 8. So here either or means what? The addition theorem you have to use it as. So this is an application of your what? The addition theorem. So what is the sample space if 2 dice are rolled? Sample space is what? 6 square, which is 36. Yeah. So there are two different events. So event A, if I take it as, it must be a what? The prime number. That is the first die should contain a prime number. So first die should contain a prime number means what is that first die? First die should contain a prime number. So what are the possible cases you are having here? First die means what? Prime number 2, 3, 5. And first one will be what? 2, 1, 2, 2 and so on 2, 6. Similarly 3, 1, 3, 2 and so on 3, 6. Similarly you will have it as what? Sorry, only one thing will be there. No? Yeah. 5, 1, 2, 3, 5. So which is a 5, 2 and so on. You will have it as what? 5, 6. So this is a 6 will be there, this will be 6 and this will be what? 6. So total will be what? 18. So now what's the probability of A? What's the probability of A here? What's the probability of A? Total I am having here possible cases are what? 18 divided by 36. Then similarly B. What is the event B here? A total of 8. A total of 8 I am having. So this prime number is what? On first day, only first day. That is the reason why 2, 3 I had taken. Yeah. Second means what? That is event B is a total of 8. A total of 8 I need to do it as. So a total of 8 will be what? What are the possible cases you are having total of 8? Total of 8 will be what? 4, 4. Yeah. 5, 3 and 3, 5. Then 6, 2 and 2, 6. These are the possible cases. Am I right or not? So here how many will be there? Total 5 will be there. So what's the probability of B? What's the probability of B, 5 divided by 36. Am I correct or not? Yeah. You can cross verify it as first die should contain a prime number. Check it out. I think this will be there and this is also will be there and this also will be there. So I think 3 is a common of that one. So hence one more thing, it is probability of A intersection B will be what? This 3 is common. You can check it out. So 3 divided by 36. So check it out in the A event. This also will be there. This also will be there, and this also will be there. So these are the what? Common things. Am I right or not? So hence what I need to do it as here probability of either A or B. So that is the reason why A union B is equivalent to, you know, that the probability of A plus a probability of B minus probability of A intersection B, you can do it as. So what you will get as here probability of A is how much? 18 divided by 36. Probability of B is what? 5 divided by 36 minus probability of A intersection B is what? 3 divided by 36. So 18 plus 5 all are the common terms. So hence I can represent as what? Yeah, hence I can represent as what? 18 plus 5, which is 23. 23 minus 3, 20. So that is 20 divided by 36. So how much you will have it as? 20 means what? 5. You can cancel it as 5 4s, 5 9s. So hence you will have it as what? 5 divided by 9. It is the answer. Right? Getting what I'm saying here? Yeah, that is a possible case. Okay, fine. Yeah, so that is the thing which you have to keep in your mind to solve the problem. Yeah, next, let me take one more problem. That is a problem number 4. Yeah, again, 2 dice are rolled. 2 dice are rolled. Find the probability that neither sum 7 nor sum 11. Find the probability that neither sum 7 nor sum 11. So this is the question. Am I right or not? Yeah. Can you solve this? Again, 2 dice are rolled means sample space is 6 square, which is 36. You will have it as that, you know that. And they are asking neither sum 7 nor sum 11. So let me take what is your sum 11? or sum 7. Take event A, this is event A. If you take it as, what are the possible cases of sum 7 here? We'll have it as what? 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, next 5 comma 2 and 6 comma 1. So total how many will be there? 1, 2, 3, 4, 5, 6 will be there. Can you tell me what is the probability of A? Probability of A is what? 6 divided by 36. Then similarly B, sum 11 you take it as. Yeah, sum 11 means what? Only two cases. One is 5 comma 6 and the other one is what? 6 comma 5. So you'll have it as these things. So then what's the probability of B? Which is 2 divided by 36. So they asked you what? Neither sum 7 nor sum 11. So that is the probability. Probability of what? A complement intersection B complement. This you can represent as what? Probability of what? That I already mentioned you earlier. Neither A nor B. Yeah, you can remember here. See, you can practice so that you can have an idea. What is this? Neither A nor B. Here you are having what? A intersection B complement. So probability of A intersection B whole bar you can represent as. So that is what you have to keep in your mind. So A intersection B whole bar, if I write it as, then it gives you what? 1 minus probability of A union B. So again this will be happens with what? 1 minus probability of A union B means what? Addition theorem. So which is probability of A plus probability of B minus probability of A intersection B you are having. So if you check it out here, this is having a same sample space then occurrence of A and occurrence of B. Check it out, your event A and event B. These two are what? These two are what? Occurrence of one event does not depends upon the occurrence of the other event in the same sample space. This I can call it as what? Mutually. This I used to call it as a mutually exclusive events. This I used to call it as mutual exclusive events. For a mutual exclusive events, probability of A intersection B is what? 0. For a mutual exclusive events, probability of A intersection B is 0. So hence this directly I can make it as what? 0. So hence you can substitute the values of this. You will get as the answer 1 minus probability of A is what? 6 divided by 36 plus the probability of B is what? 2 divided by 36. So which gives you 1 minus 6 plus 2, 8, 8 by 36. So 1 minus 8 by 36 means I think you will have it as a 28 by 36. So again with the 4 sounds 4 9. So we will have it as what? 7 divided by 9 is the answer. Clear? Getting what I'm saying? Yeah. So that is how you people have to solve the things with respect to that. Right? Okay. Yeah. And one more example, it's a very good example. You can concentrate based upon this is the interlink of your probability and the concept of your matrices. So let me take the best example. It's a good example. Yeah, a determinant is chosen. A determinant is chosen. A determinant is chosen from the set of. A determinant is chosen from the set of all determinants of order 2 with the elements. A determinant is chosen from the set of all the determinants of order 2 with the elements 0 or 1. Find the probability that the chosen determinant is non-zero. The chosen determinant is non-zero. Okay. Yeah, this is the question. So by clearly they are mentioning you that a determinant is chosen from a set of determinants of order 2. Order 2 means what? It's a second order matrix. So that is a 2 by 2 matrix. Am I right or not? So order 2 means what? It's a second order matrix. That you know that very properly. Am I right or not? So if I take A is a 2 by 2 matrix, which is A is a 2 by 2 matrix. If I take it as just I am taking an example, A B C D is my matrix. So from this my sample space, which is nothing but what ma 2 to the power of 4, it's 4 elements are there, total 4 elements, and it's an order of 2, so we'll have it as 2 power 4, which is 16. Am I right or not? Yeah, so this is the case. Then what is the determinant of this one? That you know that for a 2 by 2 matrix, determinant of A is what? AD minus BC, you know that. So now what they told you in the problem is the chosen determinant is non-zero. So here for getting this with an elements of what ma? Either 0 or 1. With the elements of what? Either 0 or 1 they are told. Am I right or not? So regarding that, how you people have to do it as? What you will do? What you have to do it as? So this is about that particular criteria. So now there are two options. Non-zero means what? So here there are three different options while performing the determinant of a matrix. So either you will have a 0 or non-zero means what? Either positive as well as your what? Negative. So both the cases you have to understand here. So that is the case 1 if I consider here. Case 1 means I will go with what ma? My determinant. Determinant of A, which is 2 by 2. I am just taking it as what ma? A positive. I am just taking it as a positive. So when it will happens, because my elements are what? Because my elements are what? Either 0 or 1. So when it will happens, you can check it out my here. So A and D must be is equivalent to 1, right? This is, and B and C, either it may be a 0. So this is the case because AD minus BC, if I want to make this as a positive with the elements of what? Either 0 and 1 only. Either 0 and 1 only. So can you check it out the possible ways here? You can cross verify the possible ways. Determinant. So can go directly. The determinant is, you can go with. So there are 4 possible cases will be there. So that determinant A and D. AD must be what? It is a fixed value. A and D value will be fixed. Am I right or not? So you can take or else you can go with matrix only. You can go with the matrix wise so that it will be easy. A and D will be fixed value. This A and D value will be fixed. A and D value will be fixed. So that you will have an option of what ma? Either 0, I mean the determinant will be a positive, you will have it as. Am I right or not? So this is the case, you can cross verify it as. So now if I take this B and C, either 0 or 1 ma. First I will take it as what? The first case, both are 0. Then this is 0 and 1. Then this is what ma? 1 and 0. Then it is what? 1 and 1 case. So if you take this last case ma, this last case determinant is what? 0. So but it is not required for us. So hence only these two cases, sorry, these 3 cases. Check it out. In these 3 cases you are having the determinant is what? The determinant is what ma? The positive value. So hence I will take it as what? Here with respect to these 3 possible cases will be there. Then similarly case 2 if I consider it as the determinant, this determinant of is second order matrix is nothing but what ma? Negative. So in which if I want to make this as a negative, reverse case, B and C must be is equivalent to what? 1, and A and D is equivalent to what ma? Either it is a 0 case. Am I right or not? The same analysis. Whatever the analysis you done for your earlier case, the same analysis I have to do here for this. So now if I take B and C, I am fixing it as what ma? 1 1. Am I right or not? So B and C will be 1 1 and I am fixing. Am I right or not? Yeah. Then either A and D is nothing but what ma? What? 0 and 0. So the same case again you substitute here. A and D is 0. This is 0. This is 0 and 1. This is 1 and 0. Then this will be what ma? 1 and 1. This you know that it is a 0. So these three, rest of the 3 will be what? The same. So hence you will have it as what? Here this is 3 and this is 3. So they asked you what ma? The probability of what? Non-zero determinant. So can you tell me what is the probability of non-zero determinant? Probability of non-zero determinant. So which is nothing but what? This is 3 by 16 because the sample space is 16. 3 by 16 plus 3 by 16 which is what ma? 6 divided by 16. So this is the answer. This is how you people have to do it as. Am I right or not? Yes or no? Yeah, that is how you have to do it as. Right? Sometimes if they asked you non-negative determinant, if they asked you, I'm just extending this one more. Non-negative determinant. Non-negative determinant means what? This is non-zero determinant and this is what ma? Non-negative determinant. Non-negative determinant means what? Either 0 or what? That. So hence you can take it as what? 1 minus 3 divided by 16, which gives you what? 13 divided by 16 minus 3, 13 ma, which is 16. Similarly, one more thing, which is what? Zero determinant. If I asked you, what is zero determinant ma? Non-zero will be what? 6 by 16. Non-zero zero determinant means what? Zero determinant means what? 1 minus 6 by 16. So which is nothing but what? 10 by 16. Am I correct? So likewise, you can extend the problems like this. Are you getting what I'm saying there? Clear na? This is how you people have to solve the things regarding that criteria. Getting what I'm saying? Yes? Yeah. And let me take some more problems. After that, we will solve the previous questions. Okay? Yeah. That die is rolled. If the number is odd number, then find the probability for that. I just given you already. Yeah, next one more problem. Sixth one you consider it as. Yeah, it is also a very good example, ma. Yeah, a number is chosen. A number is chosen. A number is chosen. Yeah, a number is chosen at random from the 100 numbers. A number is chosen at random from the 100 numbers. Yeah, continue it. A number is chosen at random from the 100 numbers. Those are 0, 0, 0, 1, 0, 2 and so on 99. Let capital X denotes the sum of the digits on the number, and capital Y denotes the product of the digits on the numbers. Then find the probability that is a probability of X is equivalent to 9 given Y is equivalent to 0. This probability you have to calculate it as. This is the question. So try to understand this question, ma. A number is chosen random from the 100 numbers. Those numbers are 0, 0 to 99. Let X denotes what, ma? X is sum of the digits on the numbers and Y is what? The product of the digits on the numbers. That you have to keep in your mind. And they asked you what? The probability of X is equivalent to 9 given Y is equivalent to 0. So this is what, ma? The conditional probability that you know that. Right? This I can represent as what? A probability of X is equivalent to 9 intersection Y is equivalent to 0 divided by what? Probability of Y is equivalent to 0. This you have to do it as. This is how I have to calculate. This is the question they had given. Then X means what? Sum. Am I correct or not? So where X is a sum and Y is what, ma? The product. So sum 9 and product is what, ma? 0. So can you check it out here? What is X is equivalent to 9, ma? Sum must be 9 and the product must be what? 0. That is both intersection. So what is that possible case we are having? What is the possible case of you are having, ma? See, what is the probability of X is equivalent to 9 intersection Y is equivalent to 0? What are the possible cases you are having here? What are the possible case? Sum 9 and product 0. Sum 9 and product 0. Sum 9 means 0, 9 and 9, 0. Product this. Only these two things will be there. So hence 2 divided by 100 you will have it as. Then similarly, what is the possible cases of your probability of Y is getting 0? What's the probability of getting Y is equivalent to 0 here? Yeah, you have a lot of things will be there. So that is 0, 0, 0, 1, 0, 2, 0, 3, 04, 05, 06, 07, 08, 09, and then one more again 10, 20, 30, product 40, 50, 60, 70, 80, and 90. So these are all the total possible cases. If you count it, you will have it as what now? If you count it, you will have it as total 19 things will be there. So what is the probability of this? What is the probability of this? So you will have it as what? 19 divided by 100. So now that value is nothing but what? A probability of x is equal to 9 given y is equal to 0 is equal to that. You will have it as what? The answer for that, which is 2 by 100 divided by 19 by 100. So which gives you what? 2 divided by 19. That 100 will get cancelled. So this is how you people have to solve the problems based upon these conditions. So this is about this particular criteria. In the next session we will start with some more previous questions. Some more previous questions we will solve it as, and then we will conclude that session. Clear with my point? Some more problems we will solve it as. Then once if you are completed this one, we will go with the Bayes theorem and total probability. Then we will go with the distribution as well as the density function. Okay, in the next session we will continue with some more problems. Okay, fine. Yeah, thank you.